Okay. Hello. Good morning. Roar. Here's a warm up. Woo. Oh, too much. Can't see it all. Sorry, I'm trying to find the right size that will get all questions on the page. So we're a bit behind. Sorry for being out. Today we're doing mostly derivatives of trig inverses and then other trig functions or other inverse functions. It's a 2-day homework assignment, meaning I'm not sure we're gonna get through everything. So today and Monday, try some of the homework. You should be able to do half of it. It's out of the textbook. Test is projected to be a 2-day test, not next Tuesday, but the Tuesday after. Tuesday and Wednesday.
What is your calculator?
You can just leave it as a messy fraction. But, I mean, if you want to use a calculator, sure. Because this one is a nasty number, right? Did anyone actually get out a calculator and do the number? 54.5. So the point of the first question is to remind you, like, the point of implicit differentiation. Some of the homework questions, it was gave you R and theta and asked for how does the radius change per time? It's just a unit change. Well, there's this, it's spinning at this rate, there's this many angles per second, so d theta dt was this. So you can keep changing, it's just doing unit conversion. And it takes a minute to think about. And also with the homework, if you forgot to do the implicit differentiation, like, and the derivative of y with respect to x, in the end, you've lost what you're looking for. You need to define dy dx. And if you didn't ever do that, it's a hint that you're forgetting implicit. Sophie, what's the derivative of this? We want to find dy dt.
So first you take the derivative of sine, which is cosine of 5x, and then multiply it by the derivative of the second side, which is just 5. So it's 5 cosine of 5x.
What's on the other side?
Dy over dx.
Dy dx, but the problem asked for
3.
dy dt. So what's one adjustment that I can do, Sydney, to fix it?
You could say dy dt equals cosine 5x dx dt.
Say that again?
Dy dt equals cosine 5x times 5 dx dt.
Okay. So like this unit conversion, I had feet per second, and I'm going to change it feet per hour. This is a way of changing the units. So this gives me dy dt now. And they're telling me dx dt is 3. So dy dt is 15 cosine 5x. All right. The last one, does anybody remember these from Calc?
You make the triangle and then you label your theta and then you
Triangle, label your theta.
and you can secant that means like the hypotenuse is gonna be 5 and next then on the bottom is gonna be 4, so across is 3.
Okay, so telling you that secant theta, positive secant theta, is 5 over 4. I should have also said that it's quadrant 1, but if it's restricted, it's quadrant 1. And so Ari said secant is cosine upside down, so it's hypotenuse over adjacent, 5 over 4. He knows the 3, 4, 5 triangle, so the opposite is 3. So what is tangent of theta?
3/4.
3/4. Okay. Yeah. All right. Just quick to go through these. We did domain restrictions for trig functions during the first week of review. For sine inverse, we want to choose a region that gives me all of the y values from -1 to 1. So sine inverse is restricted from -π/2 to +π/2, inclusive. Cosine, to get all of its y values from -1 to 1. inclusive 0 to pi. Tangent, AP exam is obsessed with tangent, tan inverse, just all of it. It loves tangent because it does lots of great things. Tan inverse is almost the same thing as sine,
But non-inclusive.
but not inclusive. Wow, and I can't write anymore. Okay. Round. Pi over 2, comma, pi over 2. Okay. So, Clara over here, capital, so that means restrict, arc sine -1/2. So it's gotta come from this. Okay, where's sine 1/2? Anyone? Pi over 6. So, but I wanted it negative. Across from pi over 3 is √3. So where is sine 1 over 2 at pi over 6? And we wanted it in a quadrant where it's negative, which is that one. Negative √3 over 2, Nick, where's arc cosine negative √3 over 2?
It's 5 pi over, -5 pi over 6.
Okay, let's look. So on the triangle adjacent is here. So the reference angle is pi over 6, and cosine, I want it here. You had it right the first time. Positive 5 pi over 6. Does it make any sense or no?
Oh, because it's arc, it's going from the top.
Well, arc, capital A arc is restricted to the domain that we are stuck with.
Oh, yeah, I got you.
So that negative value is coming from, terrible graph. It's down here, one of those. Arc tan -1. Gus, where is arc tan -1?
So it has to, since it's negative, it has to be in the fourth quadrant. So and since it's -1, it's got to be negative pi over 4.
Negative pi over 4. Yeah. Okay. So these are reminders because we're going to do derivatives of the inverse trig functions today, and then something that's going to feel completely different, but it's just derivatives of inverses. Okay. Here's a thing that's kind of important. I used to blow it up, but I've seen how they ask these tricky things about it. If f is differentiable at every point in an interval, and the derivative's never 0, then the inverse is differentiable everywhere. And the big deal is that the derivative is never 0. Why is that important? So all those trig functions that we just had to make restrictions, for the inverse to exist without restriction, it needs to pass the horizontal line test. Sine and cosine fail the horizontal line test like everywhere. And if I tell you that it's got to be continuous and differentiable everywhere, and never have a zero slope, that means it can never, it's not allowed to turn back on itself. So it can never not pass the horizontal line test. That's what this restriction does, is if the function itself never hit a zero on the slope, it could have never turned around and like, failed the horizontal line test. Okay. It's just a small detail that they throw out sometimes. Okay. Here we go. Okay, I want to do the derivative of arc sine. I don't know how to do that. What math operation do I need to do to undo arc sine? Sine. Okay, thank you. Yes. What is sine of arc sine of x?
Arc, X,
Yeah, like probably x. Okay, all right, cool. Fiona, what is the derivative of sine?
Cosine.
Cosine. And it's of y. Josh, what is the derivative of y with respect to x?
dy over dx.
excuse me,
Miriam, what is the derivative of x with respect to x? 1. Okay. Oh, this wasn't so bad. dy dx is, oh,
I got dx arc sine x is equal to negative sine negative 2x cosine x.
not sure where you're getting that.
It just follow the rules online.
Okay.
I used the chain rule.
Okay, well, right now, I don't see where that's coming from, but, so right here, I have the issue that I have, stuff with y in it, and I wanna get stuff back in terms of x. So, from the warm-up, Ari told us, we'll draw the picture. The angle, what's the name of the angle?
Y.
Y? And sine of y is x, so how do I label the sides?
Hypotenuse is 1, and then side opposite is x.
Hypotenuse is 1, side opposite is x. Camden, how do I find this side?
You do the,
That thing,
I forget.
Pythagorean theorem.
Yeah.
Okay. So a squared plus x squared equals 1. Gross. So Annie, now looking at this triangle as we have it labeled, cosine of y, well, 1 over cosine y. What is secant of y?
1 over, or 1
Yep.
minus, 1 over 1 minus x squared, or root.
Get that, gross. It's 1 over 1 minus x squared. There you go. The derivative of, yeah,
For the finding like the other side, doesn't it have to, how do you know that it's like a right triangle to use the Pythagorean theorem?
Okay.
Oh,
It's the same thing. It's written right here. That's the derivative pattern. It just looks nicer on the other page. Sorry. That was sine of y equals x. Trig functions work on right triangles. So that it says sine of y, that's in a right triangle, which is why we drew this triangle here and labeled it. The thing I was expecting was, why didn't why isn't it plus or minus? And because I want this to be length, so it's positive. Yeah,
The reason we did all that stuff with A is because we can't leave it in terms of Y. Why not? Because it
what's the
wants it
derivative
in
of arc
the-
sine of x, and you're telling me, well, it's secant y. I don't know what that is.
I got you.
So there it is, pretty, again, Amir, sorry about that. And I haven't seen them be mean about this. This restriction, you can only do, the things that come out of sine are stuck between -1 and 1. So the things that you can put into sine inverse, when is sine 2? Well, it isn't. So you can't do sine inverse of 2. You can't do sine inverse of 1.001. You can't do anything bigger. We've, oh. It's so strange when it decides to like have weird stuff. Okay. We'll just leave that covered up. We have cosine inverse, exactly the same thing, but it's contrary, contrite, pick something counter, something negative sounding. Derivative of cosine inverse is just negative, the same thing. So the ones that begin with C, yep, pattern holds true. They are still the negative. So just to practice it, what's the derivative? Ethan, what do you think? So the pattern was what would it be?
Would it be 1 minus the quantity 8x squared?
And then there was that gross du dx next to it. What is that?
I don't know.
Chain rule.
Oh,
What's the derivative of that?
so it would be. Wait, so the derivative of 8x squared, it would be 16x.
Not a lot to simplify on this. But 8x squared, he said, a quantity squared, and so that is implying that he included the exponent of the 8. That's it. Okay. Ready for the next one? Part A. Same thing. Y equals arctan. I don't know what that is. What operation undoes arctan? Tangent, okay. Should I draw the triangle now? I feel like we're gonna need it. Jasper, how do I label the triangle? The angle is Y.
Y.
Opposite is X. And do I know the hypotenuse or the adjacent? Adjacent is 1. Clara, what is the hypotenuse gonna be?
1 plus x squared.
Under the square root. Okay. Preston, what's the derivative of tangent?
This is secant squared.
Secant squared, and this time it's y. So Jamie, what do I need to add on? Implicit differentiation. What's the derivative of the thing inside?
dy.
dy over dx. Alex, the other side, what's the derivative of x? 1. Okay, so I could divide by secant squared, which is multiplying by cosine squared. Okay. What is, question, all right.
Like, how did tan y equals x to secant squared y 1? Where did the x go?
Okay. We did the derivative.
No.
Derivative of tangent is secant squared. Derivative of y is dy dx. Derivative of x with respect to x
Oh,
is
this one. Oh, that makes sense.
Okay. Remember. What is cosine of y looking at the triangle?
Whatever.
And I wanted that squared, so it's just something pretty like 1 over 1 plus x squared. Perfect. Any questions on this, or can I show you it pretty on the next page?
Why did we want it squared?
Because the derivative of tangent was secant squared, so cosine of y, looking at this picture, is what Millette said, but this problem was squared. Squared, squared. So Kelly, take a wild guess, what's the derivative pattern for cotangent?
Negative.
Negative that, yes. So this is one of the reasons why AP exam is obsessed with tan inverse. This derivative is beautiful. Like I would say so myself. They're going to integrate it a lot, and they're going to hide it, but you're going to know better. Oops on it.
Like on a test, are you gonna ask us to like prove all of this, or should we just?
Hell no. No. This is to give you inspiration for wanting to memorize the patterns, and I have a story for you.
Like doing like this is better than like the limit and stuff, so I just wasn't sure.
Yeah, no, you don't need to prove these. Though I've had people do it on the test because it was fun. Okay, that kid just got a PhD in math from UT Austin, so yeah. He stopped by and I was like, oh, what's your research on? And he's like, well, just call it geometry. I'm like, you look highly esoteric, theoretical, geometric math. Anyway. So practice the pattern. What's this guy? And Alex, I didn't even write it down what the pattern for cotangent was. Because Kelia told us. Roxana, is it gonna be positive or negative?
Negative.
Negative because it begins with a C. What problem with the rest of it?
1 plus x squared squared to x to the fourth, and then times 2x.
Okay, so, the two you really need to know are arcsine and arctangent. And like, I've never seen arcsecant come up. And then reading the coolest Facebook page ever, calc teachers across the nation, they don't and won't put on secant because there's an argument about whether there's absolute value bar or not. Anyway, I'll show it to you. We'll do this quickly. But supposedly they will not ask you about it. So secant y equals x. Secant is adjacent over opposite. Derivative of secant tangent. And then implicit differentiation, because if I don't do that, I've lost my derivative entirely. So this is cosine y, cotangent y. All right. Cosine of y is x over 1. I'm doing something wrong.
Switch it. Flip the triangle.
Yeah.
Or should it actually be the hypotenuse?
Yeah, that should be.
X should be the hypotenuse. Like, I know this, I'm doing it wrong. Okay, sorry. Hypotenuse should be x, and that's 1. And these guys are backwards. So it's 1 squared plus a squared equals x squared. That's better. This is square root of x squared minus 1. And the reason that I've had the graphs of these up in the corner is to show you that the slope of secant over its whole domain, which is the argument that people are saying is other people move the domain somewhere else, it's always going to be positive, so it has these blasted secant sucks absolute value bars. But again, they will not ask you.
So you can write this down.
For grins, there is one homework question that uses it, and I did not remove it. It was already printed before I saw this. And you know, it's like that weird cousin that still shows up at the family reunion. You gotta be like, okay, that'd be nice. Okay, so like I said, I don't know the ones that begin with C because I don't need to, I never use them. And you don't have to. But it's helpful to remember, oh, if you're asking me about derivative of arc cosine, that's just negative whatever arc sine is. Massimo, what trig function did you learn first? Sine. Okay. So here's the stupid way to remember these. Sine begins with S, so there is a square root, a squared, and a subtract. And you learn sine first so that one goes first. Jamie is not impressed. Okay. All right. Secant. You did not learn secant first, but it has an S, so it has a square root, a squared, and a subtract. We didn't learn it first, so it's at the end. And why this? Because secant sucks. It just does. I don't know. You gotta come up with your own thing. Tangent does not begin with S, but the little t looks like a plus, and it's still got a squared, so I don't know why that's there, but it is. Yay! Okay, well, that's all I got. Those are the two you really need to know. And by really need to know, by recognizing the pattern, they will ask about this one for sure. And it's not so much that you need to know that how to do the derivative of this, it's more that you need to be able to integrate. And just like walking forward is easier than walking backwards, adding is easier than subtraction, multiplying is easier than to divide, derivatives are pretty, quote, simple. Integrating, undo a derivative, sometimes it's like, well, because I know this, I know how to. Like, if they, the integral symbol is that little squiggle. You gotta look at this and be like, oh, well, because I recognize the pattern, I know it's gonna be tan inverse. Yay, they're gonna ask that, just lots. Alex, you ready for that? Yeah. Okay, so that's trig inverses. The patterns, know these two. The tiniest bit of time. So there is a whole second thing that I need to get through, and I'm not gonna have enough time, but I wanna start it. Like I said, the homework assignment on the page is a 2-day textbook assignment. Day 1 is basically practice the trig derivative patterns. If you get to some questions, which they're probably not on there because there aren't many in the textbook, but derivatives of just inverse functions. How do we find the inverse of the loop suggestion? How do I find the inverse?
Reflected over y equals x, right?
Yeah. So I trade x and y?
Yeah, and then solve for y.
Six times 3/2, 9? I don't know. Brain's not working this morning. Fiona, what is f of 9? Plugging in, plug it in. That would be 6, 12. 6 plus 6, so it's 12. Josh, what is g of 12? That's plugging in here. 9. Is it an accident that no? Because that's what inverses are. Put in this, get out. Put in A, get out B. If you put in an inverse, put in B, you get out A. Name already appears. Output ID number. Input ID number. Output already is me. Because nobody else should have his ID. Okay. Preston, what's the derivative of f of x?
2/3.
2/3. Annie, what is the derivative of g of x?
3/2.
3/2. Here's the thing, it's so close to perpendicular, but it's not. What's the difference?
It's not negative.
It's not negative. They're just reciprocals.
Yeah.
Okay. And I picked a linear function for these just to start the example, but if they're not linear, it's just become a mess. All right, I will show you. The bell's gonna ring in the midst of this, but I will show you. Don't go down, just. This is, that's what the derivative is. Okay, it's just a picture, don't panic. You guys said, okay, no. Shh, happy place. But I don't even remember who I asked about what's the inverse. And you're like, oh, it's just reflected over the y equals x. So the dark black line is the original function. The gray one is the reflection. That's all. Don't be panicked. It's okay. Yeah? And you guys said this coordinate, AB, well, that coordinate's going to be BA, right? Not that bad. You knew all this already. You just never looked at it. All right. So this guy's slope was rise over run. This guy's, it's just the reciprocal. Here's the catch. It's f prime at A, that equals m, and it's too hard for me to write f inverse prime, so I'm calling it g of x, but that is f inverse derivative. The derivative is going to be the reciprocal, but at what coordinate? What value? B. So when you're like, well, it's at x, well, this guy's x is that guy's y. So this is the tricky wrinkle of inverses. We'll do this more on Monday, but the counterpart coordinate of the inverse. So it's not a hard concept, but it's funny looking. So let's see. I mean, given the only information I gave you, there's only one answer that this can be. But I'm going to just define, I'm going to say f inverse is g. So what is the one coordinate I know on g? Because they're inverses.
3.
Coordinate.
5,3.
G of 5 is 3. Okay. So g prime of 5 is 1 over f prime of 3. Yes? So, yes, no? No, okay.
Why?
Why? Okay, this function here had a slope of 6, up 6 over 1. My counterpart function, when I flipped it over, counterpart function, the inverse, that run became this guy's rise. Okay, so more of this on Monday, but do the textbook stuff that is involving trig inverses, and we'll come back to this. And then I'm gonna look on Del's math. I think they have good examples of these. Your book does not. So that'll be Monday.